Welcome to the video on Bayes' theorem. So Bayes' theorem ultimately comes to a formula for determining conditional probability that helps with calculations where the entire Venn diagram or table of data isn't given. So for two events, your probability of A given B is equal to your probability of B given A times the probability of A divided by the probability of B. So we could draw a tree for this where you have your probability of A and your probability of not A. Then you would have your B. So this second one would be probability of B given A is true. And then we'd have probability of not B given A is true. And then down here, we would have our probability of B given A is not true. And then our probability of not B given not A. So to find our probability of A given B, we need to look at the branches where B is true. So this is the one where you'll have your A given B. So it would be probability of A times the probability of B given A. And then we're going to divide it by both of the branches together, which add up to the probability of B. So this is where your Bayes' theorem comes from. And you can expand that to three events, where your probability of A given C is your probability of C given A times your probability of A divided by the probability of A times the probability of C given A plus the probability of B times the probability of C given B. So the IB test will only require Bayes' theorem is used for a maximum of three events. So here we have our first IB practice question. It says, Jack is shooting free throws. His probability of making the first shot is 40%. If he makes the first shot, his probability of making his second shot goes up to 50%. If he doesn't make his first shot, his probability of making his second shot drops to 20%. Given that he made his second shot, what is the probability that he made his first shot? So we'll label these as S for second shot and F for first shot. So it says, given that he made his second shot, so we're given that he made his second, and we want to find the probability that he made his first. So your probability of F given S is going to equal your probability of S given F times the probability of F divided by your probability of S. So we can look back in our question, and we can even draw a tree map. So for our tree, we have the first shot, and then we'll figure out our probabilities for our second shot. So his probability of making the first shot is 40%. So the probability of making it and the probability of missing it would be 0.6. If he makes the first shot, his probability of making his second shot goes up to 50%. So then the second shot, he can make it or he can miss it. If he doesn't make his first shot, the probability of making his second shot drops to 20. So then not making it would be 80%. So your probability of making your second shot, given you made your first shot, would be this right here. Because we're given he made his first shot, so the probability is going to be 0.5. So this equals 0.5 times the probability of making the first shot, which is 0.4, divided by the probability of making his second shot. So there's two branches where he could make the second shot. So to figure out those branches' probabilities, you'd multiply each of the things. So this here would be 0.4 times 0.5, and this one down here would be 0.6 times 0.2. And that'll give us the total probability of making the second shot. So we'll have 0.4 times 0.5 plus 0.6 times 0.2. So this equals 0.2 over 0.2 plus 0.12, which equals 0.2 over 0.32, which is the same as 20 over 32, where you can divide both by 4, you get 5 over 8. So there's a 5/8 probability. So given that he made his second shot, the probability that he made his first shot is 5/8. And 5 divided by 8 is 0.625, so that's going to be 62.5%. So there's a 62.5% chance that he made his first shot, given that he made his second shot. So that's that problem. Now we have our second IB practice question. It says Abby is buying clothes from online. The product condition can be rated as okay, good, or great. So we'll call these okay, good, or great. 36% of the clothes are rated okay. So the probability that it's okay is 36%. 44% of the clothes are rated good. So probability that it's good is 44%. And the rest are rated great. So the probability that it's great is the remainder. So you start with 100% and take away the probabilities of the others. So 100 minus 36 minus 44 is 20. So you have 20% that are rated great. It says if the product is rated okay, so given that the product is rated okay, the probability that it's actually okay is 94%. So the probability it's okay, given it's rated okay, is 94%. If the product is rated good, the probability of it being good is 83%. Probability of it being good, given it's rated good, is 83%. If the product is rated great, the probability of it being great is 67%. So the probability of it being great, given it's rated great, is 67%. Given the product description matches the actual condition, what's the probability it's a product in good condition? So we want the probability of good given that it matches. So that's going to equal the probability of matching, given it's good, times the probability of it being good, divided by the probability of it being okay, times the probability of that one matching, so times the probability of okay given okay, plus the probability of it being good times the probability of that one matching, so probability of good giving good, plus the probability of it being great times the probability of that one matching it, so probability of great giving great. So this is how we're going to calculate it. So the probability of it matching, given it's good, would equal the probability of a good one given it's good, because that's its probability of matching. So that's going to be 0.83 because it's 83%. So we'll have 0.83 times the probability of good, which is 0.44, divided by the probability of it being okay times the probability of okay given okay, plus the probability of it being good times the probability of it being good given that it's good, plus the probability of it being great times the probability of it being great given that it's great. So this is our problem, and you can go ahead and enter those numbers into the calculator, and then you'll get the probability is 0.436. So given that the product description matches the actual condition, the probability it's a product in good condition is 0.436, or 43.6%. So that's how that problem would be done. So in summary, Bayes' theorem is a method for determining conditional probability that helps with calculations where the entire Venn diagram or table of data isn't given. For 2 events, you would use this equation, and for 3 events, you would use this equation. And the IB test will only require that Bayes' theorem is used for a maximum of 3 events. That's all for this video. Thank you for watching.